All right, last time we were going through the different types of data, and we were partway through section 1.3 whenever we stopped. And so one of the things that we had talked about was, well, the differences between parameters and statistics as far as for the population or for a sample. We talked about the difference between quantitative data, which had numbers, versus categorical or qualitative data, which is just names or labels. When we talked about quantitative data, we were talking about the difference between discrete and continuous. What is the difference between discrete and continuous? Actually, let me word it differently. Can anybody give me an example of either discrete or continuous data? It has to be quantitative, so it's got to deal with numbers. Okay, discrete would be like counting the number of students. What would be an example? Let's just take our students. How can I turn that into continuous data? What can we measure on the students that would be continuous? Okay, GPAs could be, yeah, the cumulative GPA could probably be considered continuous because you could get all kinds of fractions and decimals there. If you're just talking about the GPA for a class, that would definitely be back to being discrete. Because it would just jump. Either you got a 3.0 or a 4.0 or a 2.0. You don't have the fractions and decimals between. But if you did cumulative GPA, that can become continuous. What else? What part of the attendance? Okay, if I took the percent of attendance, it could be continuous. Because if you took the number of days they were here or days they were absent, that would be back to being discrete. So that's why I wanted to pull a little bit closer on that one. We could be measuring people's weights and making that continuous, because that would definitely be something that could, even though your scales may only measure to the nearest pound, your weight definitely fluctuates much more in between there. So are there questions between that difference between continuous and discrete data? As you're looking at the type of data, it changes what we can do with it. Because it changes whether or not you're dealing with discrete data where those fractions and decimals don't mean anything versus if we're working with continuous data. We will have to treat those differently as we go through the semester. And so recognizing those differences are going to be important. Okay, other ways that we can classify data is with different levels of measurement. And one of the types of levels of measurement, and this is the lowest level of measurement, is just nominal level of measurement. This is when it's only a name. It's characterized by data that consists of names or labels or categories only. The data cannot be arranged in an ordering scheme, such as low to high. Shirt colors would be an example of nominal level of measurement. There's not anything that says having a blue shirt is better than having a red shirt, which is better than having a black shirt. There's no given order to how we're going to color our shirts. The type of pet somebody has, nominal level of measurement, because there's nothing that says having a cat is better than having a dog, which is better than having a fish, which is better than having a chicken. The types of pets you have there's not an ordering scheme. There's not a way that you can label those. It's just those different categories. So nominal would be the name. And that, like I said, that is that lowest level of measurement because there's no way to rearrange those. The ordinal level of measurement, data that can be arranged in some order, but the differences between the data values either cannot be determined or they're meaningless. Example might be if you were talking about going to the county fair and getting a ribbon. Having a blue ribbon is better than having a red ribbon is better than having a white ribbon. But just because you get a red ribbon instead of a blue ribbon doesn't mean that you were just, a certain amount worse than the blue ribbon. It just means it wasn't as good. There's no definite measurement that you can use to say it was, 5 points better or any kind of thing. It was just better. The blue ribbon was better than the red ribbon was better than the white ribbon. So it still has an ordering scheme. And so when you look at doing those, having that order matters on there. But like I said, you can't measure those differences. It could also be if you were talking about parade floats. First place is better than second place is better than third place is better than fourth place. But It may be that first and second were just really, really close, and then third place was like way down there. Just because third place was lower than second place doesn't mean it was the same amount lower. It was just worse. Or I guess better to say that second place was just better than the third place. But as you're looking at there, there's a definite order to things, but it does not have a gap that's a measurable, meaningful gap as you're looking at doing those. When we look at the interval level of measurement, though, it's similar to the ordinal level as far as you've got that ordering system that you can do with the additional property that the distance between any two data values is meaningful. However, there is no natural starting point of 0, where none of that value exists. ACT scores is a good example of an interval level of measurement. You can't get a 0 on the ACT. You're going to get a score of somewhere between 1 and 36. Getting a score of 27 is 1 point better than getting a score of 26. Getting a score of 36 is 1 point better than getting a score of 35. That difference between there is a significant amount. It does correlate back to how many more problems you got correct on there. And so it's very meaningful. It has significance, but there's no 0. There's no natural starting point. Another type of measurement that would be at the interval level is temperature. 0 degrees Celsius or 0 degrees Fahrenheit does not mean there's an absence of temperature. You can go below 0 degrees Fahrenheit. You can go below 0 degrees Celsius. And so when you say that you're having today's 30 degrees versus when we had, today's 60 degrees versus the other day when we had 30 degrees, the number's twice the number, but that doesn't mean the temperature's twice the temperature. You cannot double temperature because you don't have that natural 0. Because there's no way to say -2 degrees is twice the temperature of -4 degrees. Those type of things just don't make any sense. And so since you cannot have that natural 0 where nothing exists, temperature is at the interval level of measurement unless you convert to the Kelvin scale. Kelvin scale that you use mainly just in science, but when you're working with that Kelvin scale, 0 degrees Kelvin means there is no temperature. And so then when you say that having a temperature of 200 degrees Kelvin compared to 400 degrees Kelvin, you have increased the heat level by twice as much. And so there you could actually work with what's the next one, which is the ratio level of measurement. If you convert temperature into the Kelvin scale, where a 0 makes sense. Within the ratio level of measurement, you still have the interval level with the additional property that there is a natural 0 starting point, and that is where none of that value exists. With ratios, saying something is twice as much has meaning. So you can double things, and saying it's twice that value is going to have some sort of meaningful value when you're dealing with that. Salaries. Salaries would be another ratio level of measurement. You can make $0 an hour, and that would be your salary. You could make $5 an hour, or you could make $10 an hour, and making $10 an hour is twice as good as making $5 an hour. And so having that where you can double the values and a natural 0 exists where none of that happens makes sense. Questions on those 4? As we looked at those, each of those 4 gained in, we started with the lowest level of measurement and we worked our way up to the ratio level being that highest level of measurement when we're talking about things. We can do more with ratio level of measurement than what you can with the nominal level of measurement. With the nominal level of measurement, when you're looking at only things in name only, we can talk about which one had the most, which one had the least, and we can compare those values, but you can't do as many different types of things. You can't average shirt colors. It doesn't make any sense. Averaging at things at the ratio level definitely makes a lot more sense because you're dealing with things that have numerical values that you can compare and do things with. And so each one of those we just gained in the amount of statistical analysis that we can do with them. Questions on anything from section 3? All right. right, section 4 then, working with critical thinking. In this section, we're going to discuss things to think about when you're given statistical data and conclusions. Do not just blindly accept conclusions drawn by others just because numbers are attached. There's a lot of times that people will see numbers just, commercials are notorious for doing that. I know I mentioned it the other day. 4 out of 5 dentists recommend Crest. Was a commercial that was on TV a lot when I was younger. And because there was those numbers associated with it, people just were drawn into thinking, wow, 80% of dentists think Crest is the best toothpaste. And with all these options out there, I should choose Crest because that's what the dentist thinks best. And so just because there was a number associated with it, people just blindly accepted it had to be true. There's a lot of times that newspapers and television reports and all that type of stuff, they're going to attach those values and just make those conclusions, and we cannot just accept those conclusions as being true just because there's numbers there. I want you guys to make sure you're thinking about things critically as you're doing it. So there's a lot of misuses of statistics. Part of the time, those misuses are evil intent on the part of dishonest people. Some people just want to come to some sort of conclusion, and they'll twist the data until they get the conclusion they want. That happens. More often than not, what happens is people just don't know any better. And you have unintentional errors on the part of people who just don't really know enough about statistics to be the ones that should be drawing those conclusions. They might take somebody else has gone through and done this great analysis on stuff and have gone through and pulled out the data, done the research, presented their research findings, and then because it looks like it's an interesting research document, and obviously the newspaper is not going to report on the whole thing, somebody goes around and just pulls out a few key pieces, and then they come to this big conclusion that's not the same conclusion that the person that did the research came to, because they just don't understand statistics enough to really be the ones that should be interpreting that data. And so you've got to be careful on how you look at stuff and how things are being interpreted. And sometimes you get somebody doing research and they just don't know enough statistics themselves to be the ones that should be drawing those conclusions. There's lots of different ways that data is misrepresented. One of those is by having graphs being presented. If we looked at this graph, this is talking about personal income per capita, and we're comparing Nevada and California. And from my graph, it looks like California is blowing the pants off of Nevada, because it looks like it's, about 10 or 15 times the amount of money they're making per capita, personal income per capita. Well, the problem, I'm starting at $30,000. Starting at $30,000, we're comparing $30,180 compared to $32,996. So yes, California is making more than Nevada, but they're making, less than $3,000 more. When you put it having that natural zero back in there, well, now it does not look like Nevada or California is making 10 times the amount that Nevada was making. Because now we can see that natural zero being back in there and having that ratio level of measurement, we can see that, yeah, there's a $3,000 increase, but overall that's not as significant as what it looked like over here. So when you're doing a graph and when you're looking at graphs, a lot of times graphs are a way that draws people's attention, and you might not feel like reading the whole entire article, but you might skim the newspaper and you might look at some of the pictures, look at some of the graphs, pull out the big captions, that kind of stuff. When you see this graph and they say Californians are making significantly more than people in Nevada, well, the graph says, wow, I should move to California. But then if you actually look at it closer, and most people don't take the time to look at it closer and say, oh, well, no wonder they started at $30,000, then you don't recognize that big differences. And so it's really misleading as you're doing these, and you've got to be careful when you're looking at things that you're reading all of it. Seeing and looking at the numbers is a key piece that they should look at as they're doing those. So you need to look at the numerical part of things when you're reading these graphs. This is another graph. Pictographs are also very deceiving. Again, draws your attention really well. Seen in this case, we're trying to compare the daily oil consumption of the United States compared to Japan. Well, and these are millions of barrels. as we look at this numerically, we can see Japan is 5.4, United States is 20.0. That's about, we use about 4 times the amount of oil. Does that look like 4 times the amount of oil? No. What did we do wrong? When I changed this, did I only change it in one direction? I'm drawing these pictures, or I didn't do it, but when you're looking at this, drawing those pictures, it went 4 times the amount horizontally, it went 4 times the amount vertically, and it went 4 times the amount in depth. 4 times 4 times 4 means it's 64 times bigger because we're comparing volumes, not just comparing in one direction. And so when you're comparing in volumes, you're comparing it in 3-dimensional. So it's really 64 times the size. Very, very misleading. Very, very incorrect. You should only change it in one direction. And having it on a bar graph is much more straightforward, much more easy to read as you're doing this. If you were going to force yourself to do it into volumes, you really need to make sure that it is proportionally still correct. So you should have still only maybe stretched it out 4 times the height as you were doing this. But just by having that volume on there, it really does distort the way things look. So putting it in a bar graph, much easier to read, much more effective way of doing things. And again, it's just showing that change in one dimension, which is accurate as you're looking at this. Samples. We talked about sample selection as being an important way of looking at things. That one of the things we'll look at in just a minute is that we want to have a nice, simple, random sample as we do things. Having a bad sample is it's a way to just start off bad, and you just really can't always usually can't recover from that. One type of sample that is very bad is that voluntary response sample, or your self-selected sample. This is one in which the respondents themselves decide whether to be included. The other day when I was at the store, it hit me that there's another one that we run into a lot, is when you go to a lot of the restaurants, a lot of the stores anymore, at the end of your receipt, they have this survey that you can take, and that if you do the survey, you might win coupons, or you might get entered into winning $10,000, all these different things to try to entice you to take their survey. These are voluntary response surveys. You're deciding whether or not you want to opt into that or not. Yes, they're trying to entice it to where everybody, even those people with the middle of the road opinions, will do it. But most of the time, I don't take the time to do this. I take the time. I've done it a very few times. A couple times when I had awesome service, I'll respond. And then there's been a time that I had horrible service that I've responded. But those times when people are just doing what they should do, I don't take my time to go tell them that people did what they should do. And so you get those extremes that are the ones that are willing to respond. Well, if Walmart takes all of these different responses that they get back from everybody, and they just assume that everybody, across the board, people are doing it, and those people that think, answering it with really good responses, then they're going to give themselves higher rankings than what it really should be. And so it's not a good sample to be able to even use to make any kind of conclusions on things. Trying to make a conclusion that says Cameron Walmart's better than some other Walmart isn't going to be very effective when you're trying to take things that are coming from a bad sample to start with. Also, something to be careful about is small samples. If I was trying to decide, how good of a teacher is Mrs. Welch, and let's just pull 2 of her students in and ask those 2 students what they thought and what their grades were, and based everything that we thought about her teaching by these 2 students, it's not a very effective way to get a good response as far as what really is true within that. When your sample base is too small, it's definitely not a good one to be able to draw conclusions from. And as we progress through the semester, we'll talk about what is too small, which gets into some interesting things as we look at things of what size we need for those sample sizes. But being careful about that. That is one thing that NCMC has been working with lately, that those key performance indicators that decide how much of the state money that NCMC will receive, part of that's based on our developmental ed students and how well they do in their next their college level class. Well, NCMC's samples are very small samples because we're not a very large institution, and our number of students that take the developmental classes and then continue on into other classes, very small numbers, and honestly, most of the time, not even statistically sound numbers. And they were trying to do it only from our fall, the students that took the Dev Ed classes in the fall, and just ignored all the rest of them. Well, we were able to go in and say, okay, honestly, statistically, you can look at this and see that our statistical, or our size of our samples are so small, it's not statistically significant. And we were able to get them to open it up to where we could use all of our Dev Ed students, because that's much more representative of ours. Now, if you went to MU doesn't need to pull students from every single semester to be able to do it. They can take their fall cohort because that's a large enough sample size that it makes sense to be able to represent what their entire student body or Dev Ed student body would look like. So trying to make sure those sample sizes are big enough is one thing to always pay attention to. And sample sizes should be something that's reported. So when you're looking at an article, you should be able to see what that sample size was to be able to determine, was that really a good enough sample size? I know I heard a report the other day, and it was talking about university students, and I can't remember what piece of it was talking about. Their sample size was 83 students from one school, and just by listening to what the sample was, how it came about, sample size alone threw that out as not being a good representation. Number one, because it wasn't a very diverse. It was just from one school, and the conclusions they were coming to, it was a strange one anyhow. Percentages. Sometimes when percentages are listed, they've got unclear ways of being said. That if you hear something say, like they improved by 100%. Well, if you hear, just hearing the word 100%, people automatically think they're top notch. Well, if I say I had a 100% improvement in, I'm trying to think of a good example of something. If I did a 100% improvement in GPAs, and I got my students to go from having a 1.0 to a 2.0, that's a 100% improvement. I still have C students, but it's a 100% improvement. Well, by hearing 100% improvement, especially associated with grades, you're thinking, wow, almost everybody's getting a 100% in her class? Not, I'm getting people getting C's in the class. So when you hear things that say it was improved by 100%, make sure you're reading it carefully, because a lot of times just having that percent in there just sort of throws people off, because you got to just really stop and think through what you're doing. Questions so far? Oh, loaded questions. If survey questions are not worded carefully, the results of a study can be misleading. Survey questions can be loaded or intentionally worded to elicit a desired response. So the way that, and a lot of times when you take surveys, especially some of those like national surveys and stuff, it sounds kind of frustrating because you get them, it sounds like they're asking you the same question 5 times. Part of the reason they do that is they're wanting to make sure their questions are not loaded, that they're wanting to make sure that the way they're wording it hasn't distorted your opinion on things. For example, and I don't want you to necessarily write these down, but think through how you would answer these 2 questions. Given the increasing burden of taxes on middle-class families, do you support cuts in income tax? So think whether you say yes or no to this one. Second question. Considering the rising federal budget deficit and the desperate need for more revenue, do you support cuts in income tax? How many of your answers stayed the same? How many of you changed your answer? Most of you changed your answer. So when you're looking at something like this, the way I word the question changes your opinion. And the question is just purely, do you support cuts in income tax? But whether I tell you, you know what, middle class people are paying way too much right now as it is, we really need to give them a break so that they can actually buy the things they need, So shouldn't we give them a break and let them keep some more of their money and cut income tax? Versus our federal government is in a mess right now. They need extra money to help pull them out of this debt that they're already in. We need to be able to help increase some of these programs that we got. Shouldn't we be willing to give a little bit more of our money to be able to help out the federal government and all the programs they have? Two completely different opinions. The question still remains, do we cut income taxes or not? But the way they word it has just already twisted things into, I know what opinion I want you to give me, and I will try to help twist that into you just give the opinion I want. And then what's worse is they'll load these questions, and then they're going to say, you know what, we got 80% of the people think, and they'll pick whichever one they want. Let's go with, obviously we are talking conservatives and liberals here. So if we went with the conservative opinion that says we want to cut income taxes, then as you're looking at this and they word it this way and they get 80% of the people to say what they want, they're going to go in there and say, President Obama, you need to listen to the people. 80% of the people want us to cut those income taxes. And so they've twisted it, and they don't say they cut that, we told them they really should do it and gave them a biased way of saying it. You just twisted it as they were doing it. So you've got to be careful, and a lot of times going back and looking at that research of where things came from is important. I know, it was that last round, right before, last round of, I guess it's been 4 years ago now, of election results. And I had one of the pollsters that were calling, and I actually took the time to go through and do the poll. And they were going through, and man, were their questions loaded. If you knew blah, 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 would you support such and such? Well, if you knew, and what they're really saying was, okay, so let's go through and find out what kind of dirt that we know they already have. Which one's going to be the most effective to spend our money on commercials? Was more what they were looking for than actually do I support certain people or not. Because they were going through the different dirt on the different candidates and asking, if you knew this person did such and such, would you vote for him? Well, if you knew this person did whatever, would you vote for him? And it was horrible. I really wish I would have written the questions down right afterwards, because at the time I was thinking, this is an awesome example for loaded questions, and I didn't write it down, and I can't remember the exact words, and I can't remember who all they were asking about, but it was horrible. So those loaded questions are definitely things to pay attention to. Sometimes it's unintentional. Just the simple way you order the questions makes a difference. And so sometimes it's just those unintentionally loaded questions. And I know that I've got it listed next. I don't want to guess with it. The book was giving you guys this example. Would you say traffic contributes more or less to air pollution than industry? Got a different answer than when they asked, would you say industry contributes more or less to air pollution than traffic? Just by switching those words, you can see a significant change of going from 45% to 57%. Because I need to compare the right things. 27% saying industry versus 57% saying industry. 45% saying traffic compared to 24% saying traffic. Just looking at whichever one was said first, people went with that one more. And if you're the one writing the questions, that doesn't jump out at me as saying, that's a horrible question. But just looking at the results they got, they found out that, okay, that is an actually really badly worded question. And that's the reason why a lot of times they'll have those questions worded several times to see if you're staying consistent. Because if you're jumping back and forth and, towards the beginning they ask you this question and you pick traffic, and then 20 questions later they come back and they ask you the same question with the order the opposite way and you say industry, then, there's red bells going off saying, I think we've got problems. Red flags or bells going off. I just put the two together. But those are things they have to look for. Also, you have to consider those people that just don't answer. Those non-responses, those occur when someone either refuses to respond to a survey question or just is not available. One of the things that's become a major change over the last 15 years or so has been the use of cell phones. That originally, when I was your guys' age, everybody had a home phone. And so if you were trying to do surveys, calling the home phones, you could usually get a really good, diverse group by just doing the random calling. Well, now that so many people use their cell phones, which aren't available for the random calling, compared to people having their home phones, aren't nearly as many, that now trying to get a good, simple, random sample by using random just phone calls doesn't get that diverse group that you want, because your guys' age group gets left out, because there's very few of you that are going to have a home phone that we could just randomly call. So just by the methodology of how they're picking their phone numbers could be a really great randomly generated phone survey, but you're unintentionally leaving out a whole generation, because not very many of them are going to have a phone to be able to be accessible. Or the mentality of the people that have a home phone, I don't know for sure, but I would assume it's going to be different than those mentality of those people that are just strictly cell phones. And so you're going to get just a different opinion based on this type of people you're getting as you're doing it. So little things that are sometimes not noticeable, but that would be a non-response. Also, when you're talking about, if you walk through the mall, sometimes you'll have people coming up to you, are you willing to take my survey? Well, the kinds of people that walk away saying, no, thank you. Or even when you get everybody to take it, and those ones that give you their no opinions, those would be part of your non-responses, that you have to look at what where they're standing on things. Missing data can be something else that we have. That can dramatically affect the results. Subjects may drop out for reasons unrelated to the study. So you might have, let me just go ahead and go with this example that I've got here. This one is a nurses' health study. The original cohort was registered nurses were selected to be followed prospectively. They would be able to respond with a high degree of accuracy to brief, technically worded questionnaires, and would be motivated to participate in this long-term study. And so they went through and figured out how they were going to determine which nurses they picked. And every 2 years, the cohort members receive a follow-up questionnaire with questions about diseases and health-related topics. And so they had this group. Well, if you had, I don't remember if it tells me how many women started with this group. They started with about 122,000 women, or 122,000 nurses. I guess it's not all women. But if you started off with this 122,000 nurses, those people that just stop answering for whatever reason it might be, I'm going to put missing data in there. And so that can distort what kind of information you're getting if there's a consistent reason as to why they're all dropping out. Another good example might be if you're doing a study on weight loss, and you're doing this weight loss program, and you start off with this big group of people that are participating. Well, if people just stop dropping off and don't keep answering, it's probably because they're dropping off the program and no longer losing weight and having maybe not as positive of results while they were on the program as those other people were. And so that missing data has distorted the things, because now when they say, well, of the people that completed our program, 80% of them lost 10 pounds or more. Well, that's because there was about, however many percent that just quit answering your questions, so they didn't complete your program. Well, that missing data is important when you're talking about whether or not this weight loss program is really a positive, effective thing to be doing. Because if during this weight loss program they kept gaining weight, and that's why they quit, well, then that's not, that data would be important in there. Another thing to pay attention to is whether it's a self-interest study. Some parties with interest to promote will sponsor the studies. Be wary of a survey in which the sponsor can either enjoy monetary gain from those results. When assessing validity of a study, always consider whether the sponsor might influence those results. So, I know I mentioned this one last time, but going back and kind of looking at it, where frequently you'll get those consumer product surveys of America. Well, maybe not frequently, but occasionally I'll get these in the mail. And so it goes through things like storage bags. Do you use Glad, Hefty, Ziploc, a store brand, or some other brand? So they're definitely giving you, they're leading you in their way they're answering things. You got Air Care, coupon use. How often does your household use Sense Off store coupons? So So that's telling them whether or not it's even worth sending you those coupons, because if you answer that you'll use them frequently, then they're definitely going to be encouraging giving those to you. And so having those parties are sponsoring this is going to be a piece of what's going on as you're doing those. So being wary of what you're getting as you're putting those out, especially when you're talking about companies that are going to get some sort of kickback as they're looking at doing things, trying to get things, verifying that their company is better than something else. I guess going back to Crest sponsoring, giving their dentist the toothpaste helps make a difference of how people might respond to those things. There are times that companies can be objective even when they're funding it. And so you can't just throw out any information that the companies come up with just to say it has to be bad. It just has to be things that you have to consider. And again, you're wanting to think critically as you're doing these. Oh, precise numbers. If a figure is precise, many people incorrectly assume that it's also accurate. A precise number can be an estimate, and it should be referred to in that way. I will be picky about how much we round and how we round our answers, because how precise they are actually says something about the accuracy of the measurements. My husband is one of them that is notorious for throwing out precise numbers, and people think he's accurate, and he's not. He'll want to say his opinion on whatever, and he'll say things like, 88.2% of people say blah, 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 blah. And I'm looking at him, and this is where we'll start disagreeing. And he's stopped doing it as much because he gets tired of listening to me going, 88.2%, really? And I will stop listening to whatever his opinion is, because now I'm focused on 88.2%. How wrong is that? And I'll be thinking through ways to question his numbers. And it is a number he has randomly pulled out of the air because he wants to start talking about his opinion being, what he's trying to say is, a lot of people say, and if he would say that, that would be great. But once you put in those precise numbers, people think they're right. If I told you something like, let's go with 1,822 people attend NCMC, well, then you're going to think that I'm probably right with my number, which I know it's a little under 1,800, but I don't remember the exact number. And it's definitely not more than 1,800 people that are attending NCMC this semester. And so by giving you a very detailed number, you think it's right when it's really not. And so you've got to be careful in making sure that those are accurate as you're doing those. So you've got to make sure that those numbers aren't being made up as you're looking at them. And how precise they do it sometimes is tricky in thinking that's actually accurate as you're doing it. So, as I said, I will be particular about our rounding errors and how we round things, because it does tell us a lot about the precision of our numbers. And we'll talk about the number of decimal places to round different things too as we go through this semester. Then we have deliberate distortion. Some studies or surveys are distorted on purpose. The distortion can occur within the context of the data, the source of the data, the sampling method, or the conclusions. So sensationalizing events to make them sound bigger and better sometimes will be things that you'll hear. But sometimes people just intentionally want to distort that data to be able to say what they want to be able to say. And you will get that in published sources that sound like they should be reliable sources. And there has been somebody along the way who has deliberately distorted things to make it sound good for whatever it is that they're looking for. And so we have to always think critically about what we see. And just because there's a number associated with it, don't just automatically assume it's got to be right. Questions? It's going to be one of the rare days I'm going to let you guys out early because I don't want to start section 1.5 today. So do the homework from sections 1.3 and 1.4. And then we don't have class on Monday, so don't come Monday. I'll see you guys on Wednesday. Our next test, I don't have one up here yet when our first test is. Our first test isn't for a while because it's going to cover chapters 1, 2, and 3. As you're doing your homework, I highly encourage you to check your answers with the back of the book. Don't write the answers out of the back of the book, but check those and compare them to make sure you're working on learning the right thing. Have a good long weekend.